We're now going to start working on applications of quadratic functions, and I'd say this is probably one of the most challenging sections of the whole course. It's not the quadratic functions that are complicated, it's going to be setting up the problems. Once we get the problems set up, then I think the rest of the work won't be too bad. So we're going to look at a couple examples, but before we do any examples, I just want to talk about the process. And this, what you're looking at here is a handout posted as a PDF in Canvas, our applications of quadratic functions, so you can print this out on your own. The process, the official word for the process of what we're going through is something called optimization in math. When a function occurs in an application, we're often interested in determining if the function has a maximum value and or a minimum value. Finding maximum and minimum values of functions is called optimization in mathematics. If an application involves a quadratic function, we know that the vertex must be a maximum point or a minimum point. Since we know how to find the vertex of a quadratic function, we can solve optimization problems that involve quadratic functions. In calculus, you will learn how to solve optimization problems that involve more complicated functions. So for us, the whole world of optimization is limited just to quadratic functions. In calculus, you do optimization with all sorts of other functions, much more complicated situations. And so let's just talk a little bit about the pictures and the vocabulary. So we know the shape of a quadratic function can be either U-shaped or overturned U-shaped. And I didn't write the letter A here, I just said lead coefficient greater than 0, lead coefficient less than 0. And we're calling HK the coordinates of the vertex in each case. So the vertex, if the lead coefficient is positive, the vertex HK is a minimum point. If the lead coefficient is negative, the vertex is a maximum point, a high point on the graph. And just a couple ways we use these words. We say the minimum occurs at the x coordinate, x equals h. The minimum value of the function is the y coordinate, so is y equals k. Now, if we have a maximum, we say the maximum occurs at x equals h, and the maximum value is the y coordinate k. So we're going to apply a process that I wrote out into 4 steps here, and you can use these 4 steps to help you set up these problems. As I go through the 2 exercises, I'm going to go through these 4 steps in each case. So let's read them over now before we go ahead and do the problems. So our step 1 will always involve identify the function that we want to maximize or minimize. Use variables to describe the quantities involved. You may use more than one variable, but eventually we need to describe the function with only one input variable. And that's really the challenge where all the work's going to be. Step 2, can we find an equation called a constraint that gives a relationship between some of the variables from step 1? And we'll see how that works in the examples. Step 3, solve for a variable in the constraint equation and then substitute into the function from step 1 to obtain a quadratic function with one input variable only. Step 4, once we get to step 4, we're almost through. Step 4, find the coordinates of the vertex of the quadratic function. Is the vertex a maximum point or is it a minimum point? Use the vertex coordinates to answer the questions from the original problem. So we got 2 exercises that we're going to work. We're going to work them in separate videos. So we'll have one video for exercise 1, one video for exercise 2, and your homework will be similar to these 2 examples that we do together in class.